Namaste students. Under the heading straight lines, let us learn how to find the distance of a point P from a straight line. For this, you will have to take a straight line L having equation ax plus by plus c is equal to 0. Let P be a point having coordinates x1 and y1. If we draw a perpendicular PM from point P onto the line L, let this distance be d. So today we will be learning how to calculate this distance d. Before we start calculating the value of d, let us first of all find out the points of intersection this line L is having with axis. This point, let it be Q and this be R. So firstly we will find the values of these coordinates. How? We know that equation of line is ax plus by plus c is equal to 0. Now if I want to find out where this line L is intersecting x-axis. X-axis means value of y is 0. So if we put y equals to 0, we will be having ax plus c is equal to 0 implies x is equal to minus c upon e. Or this we can recall from when we have written slope intercept form. At that time also we have written these values. So coordinates of q will be minus c upon a and 0. Same way, when this line is intersecting y-axis, that means x will be 0. So if we put x equal to 0 in this equation of line, we will be having by plus c is equal to 0. So y is equal to minus c over d. So coordinates of r minus c upon b, 0 and minus c upon b. Now if we join this p with q and r, what are we getting? We are getting a triangle PQR. And if we write down the formula of area of triangle, join PQ, PR. Area of triangle PQR is equal to half base. What is base here? Base is RQ. Your base into height. Height means PN. So if we calculate value of area, find out the area of this triangle, we find out the value of base, then by filling the values we get the value of distance, perpendicular distance. For finding QR, what is QR? QR is the distance between 2 points, and this we can calculate using distance formula. If we take it as x1 y1, x2 y. So using distance formula, we know that distance between the 2 points is x2 minus x1 whole square plus y2 minus y1 whole square. So x2 is 0, 0 and this is minus. So minus minus plus c upon a whole square. y2 is minus c upon b and y1 is 0. What are we getting? C square upon a square plus c square upon b square under root. So if we take out c square common and take it outside, we will be having c and take LCM, b square plus a square. We will be having a square into b square. This also can come out. So we have obtained c upon ab. So this thing will be obtained. So this q QR distance, that is the base of the triangle, its value is C upon AB into under root A square plus B square. After finding value of base QR, let us find out area of triangle PQR. Do you remember the formula of area that you have learned in class 10th as well as in beginning of this chapter? That is half x1 y2 minus y3 plus x2 y3 minus y1 and plus x3 y1 minus y2. We are having all three coordinates x1 y1, let it be x2 y2 and this be x3 y3. Now we insert the values. Half x1 is x1 only, y2 is 0 minus y3. So minus and minus will become plus. Plus x2. x2 is minus C upon A. y3 minus C upon B. And y1 is y1 only. x3. x3 is 0. y1 minus y2 is 0. So now half, what we have got? C into x1 upon B. Here C minus and minus becomes plus. C square upon AB. Multiplied with this, we get CY1 upon A. This whole term has become 0. Now, if we take LCM, by taking LCM, we will be getting area of triangle as, let's see, LCM is taken AB. AB divided by B will give A. So AC x1 plus AB divided by AB will give 1 only. So C square plus AB divided by A will give B. So BC y1. Now as you can see, one C can be taken common from all the terms. Half C taken out. Then this AB will also be taken out. C upon A. Then what are we left with? AX1 plus BY1 plus C. What we have got? This is area of triangle PQR. Base we have obtained here. So this is first. What we have discussed, area of triangle equals to half base into perpendicular distance. That means perpendicular distance can be written as 2 times area of triangle upon base. So if we insert the values from equation 1 and 2 in equation 3, using 1 and 2, using equation 1 and 2 in equation 3. So perpendicular distance is 2 times area. Area is half C upon AB and AX1 plus BY1 plus C upon this much, the value of base. So that will be AB upon C and 1 upon A square and B square. So 2 will get cancelled, this value will get cancelled, and we are left with AX1 BY1 plus C on A square square plus b square. So we have obtained the perpendicular distance d of a point P having coordinates x1 and y1 from a line L having equation ax plus by plus c. Now next topic is to find distance between two parallel lines. Suppose we are having two lines, L1 and L2. These two lines are parallel to each other. If they say find out distance between these two parallel lines, and I take a point A on first line. So if I calculate the distance of this point from line L2, can't we say D is the distance between two parallel lines also? So for finding distance between two parallel lines, simply we can obtain the distance of a point A situated on first line, the distance of this point A from second line. So here I have taken two lines L1 and L2 having equations in the slope form as mx plus c1, and second line is having equation mx plus c2. If I obtain a point A, if I get a point A on which this line L1 is intersecting x-axis, and then find the distance of this point from second line, I'll get my answer. That is the distance between two parallel lines. So first of all, let us find out coordinates of A. Now we are saying this point A is on line L1. This is the equation of first line. Here, as this line is intersecting, L1 is intersecting x-axis, so value of y will be 0. So what will be the value of x? Here, if we put y as 0, we'll be getting mx plus c1 is equal to 0. So x is equal to minus c1 upon m. So coordinates of this point we have obtained as minus c1 upon m and 0. Now after calculating the coordinates of this point, what our question has become? We have to find the distance of this point having coordinates c1 upon m and 0 from the given line L2. And equation of the line L2 after rearranging will become, if we shift this to this mx and c to this side, will be minus mx plus y minus c2 is equal to 0. So we have to find the distance of this point from this line. We have learned the formula for finding distance between point and the line as ax1 plus by1 plus c upon a square and b square under a square plus b square under. In that case, equation of line I have taken as ax plus by plus c, but here equation of line is minus mx plus y minus c2. So we will be writing d as minus mx plus y minus c2 upon a square plus b square under root. Now in place of x, we will be writing minus c1 upon m. In place of y, we will be writing 0. So our distance will become minus m into minus c1 upon m. Y will become 0 and minus c2 upon a square plus b square under root. So after cutting m and m, minus and minus, so what we have obtained? We have obtained the distance between two parallel lines can be written by the formula c1 minus c2 upon a square plus b square under root. Let's do some examples based on these concepts. First example, they are saying find the distance of the point 3 and minus 5 from the line 3x minus 4y minus 26 equals 0. Now, if we start comparing, this is point P, so this is x1, y1, and if we compare it with equation of line, A is 3, B is -4, C is -26, x1 is 3, y1 is -5. And what we have learned in the formula, distance of a point from a given line can be obtained as this. Now start inserting the values. A is 3, x1 is also 3. B, what is B? B is -4, y1 is -5. C, what is C? C is -26 upon A square plus B square. 3 square plus -4 square, 100. 9 -4 and -5 is 20 and 26. And here we have obtained 3 square is 9, 4 square is 16, 9 and 16 gives 25, and root of 25 will give 5. 20 and 9, 29, 29 minus 26 will give us 3. Mod of positive 3 will be 3 only. So perpendicular distance of the given point from the line is 3 upon 5. Second example I have taken where they are saying find the distance between the parallel lines having equation 3x minus 4y plus 7 equal to 0, and second is having 3x minus 4y plus 5 equal to 0. We have learned that perpendicular distance between parallel lines can be obtained as mod of c1 minus c2 upon a square plus b square under. So if we compare these two equations with ax plus by plus c is equal to 0. What is a? A is 3, b is -4. Now C is different, x-intercept is different. C1 is 7 and C2 is 5. Simply put the values in the formula and get the answer. We will be C1 minus C2, that is 7 minus 5 upon a square plus b square. This will give us b square plus -4 square under root. 7 minus 5 gives 2, and here we get 5. So perpendicular distance between the two parallel lines having given equations is 2 upon 5. In this lecture we have learned how to find distance of a point from a line, and second thing we have learned how to find distance between the two parallel lines.